On my office door, I had to modify the syllabus because what happened was the computer lab. Apparently, they closed down the humanities computer lab, so the humanities classes are coming to ours. So in the past, I never had problems booking the computer lab, but this semester, I wasn't able to get the times that I wanted. And so that's what, if you read those times on there, those times are the times we're going to be inside the computer lab. So I wanted it 9:30 to 12:35, but I couldn't get it because the next class is coming in at 12. And I wrote all those on red. And so I had some days that I had scheduled in the computer lab, which we can't go in because it's being used. And so I modified things. That's for next week. I'll explain it if you want regarding that. I just had the line that was drawn. But I took in that sheet, so I need to change it. So that's the syllabus on the door. We're still going to the same time, every day. Although, I wouldn't mind getting out early, 30 minutes early or 1 hour early every day. It's always nice. You take a early vacation. Yeah, maybe there are some instructors that do that. All right, what we're doing today is we're doing a lab. This was a handout lab, but I didn't send out a handout for this lab. Did you have a handout for this lab? No. Yeah. But what we want to do is we just want to focus on data collection, data acquisition, get a good data set. Sometimes when I give out the handout, there's a tendency to cookbook things. Cookbook means you just follow the instructions, which is great, right? Following the instructions, but that's not really the skills that people necessarily in the science world are looking for. For example, I took a tour of Chevron this was at the time the science club, and we started asking, what types of qualities are they looking for? Because some of the students in the science club wanted to work at Chevron because it's very high paying. I mean, it was like a six-figure control room, a job. And one of the things he emphasized was, they don't like people who cookbook. They don't like people who only can follow the instructions in the book, and that's it, because, so many different scenarios pop in and pop out, and they need people who are very flexible and who can change. And so that was the most important quality they were looking for from the students who are interested in working there. But, that quality comes in, well, how do you not cookbook? How you not cookbook is you think, okay, what are you trying to do in this particular experiment? And so, in today's experiment, what are we trying to do? What we're trying to do is we're trying to monitor something called crystal violet. We're trying to monitor the crystal violet concentration as a function of time. And there's different ways of monitoring that. And we're going to look at this reaction here, which is crystal violet chloride plus sodium hydroxide. And this is going to yield crystal violet hydroxide and sodium chloride. What kind of reaction is this? This is a batathesis reaction, where we just have a complex, or not a really complex, this is a organic cation. It's just Cv+. So the net ionic equation would look like this. It's just the Cv plus an organic cation plus hydroxide yields CvOH. Now this reaction is not difficult to monitor. With a lot of these organics, one charge has a different color than another, or one species has a different color than another. And so this turns out to be violet here in color, and hence its name, crystal violet. This product turns out to be colorless. And so what we can do is we can watch the color fade as this reaction occurs. And so what we do in kinetics is we want to see, how fast the reaction occurs. And so this reaction has a driving force. Some reactions occur very fast and very violently, and they would be explosive. Other reactions occur much more slowly. And there are certain factors that affect how fast a reaction occurs. One is the concentration, high concentration versus low concentration. Typically higher concentrations, the reaction goes faster. Temperature, typically higher temperatures, the reaction goes faster. And so what we're doing is we're doing this at room temperature, but we're going to change the concentration of this. And so the thing we want to do is we want to monitor how the crystal violet concentration changes with time. The way we're going to monitor the crystal violet concentration is by monitoring its color. And we're going to take the visible spectrum of crystal violet. The visible spectrum, this is going to be an absorption spectrum versus emission. But what does a visible spectrum plot like this? It's going to plot something called the absorbance versus typically wavelength, lambda. And so we'll monitor this over the visible range. What is the visible range of light? You guys remember? I'm sorry? 400 to, yeah, roughly 400 to 800, or 390 to, the edge of red is at 760. So 390 we call the edge of violet. Beyond the edge of violet we have ultraviolet. And 760 we call the edge of red, and beyond red we have infrared. And so between 390 and 760 we call this visible light. So 760 is red, 390 is violet. What are the colors in between red and violet? Red, okay, orange, yellow, green, blue, indigo, and violet. Roy G. Bibb, the way most people recognize this. And so what's the visible spectrum going to tell us? Absorption of light. So it's absorbing some photons. Let's see. So if something looks violet in color, is it absorbing violet photons? No, it's not absorbing violet photons. If something looks violet in color, then there are different ways that violet color can originate. And so ways to make violet. What are the ways that we can make violet in color? This is Chem 1A review. We've got to review a little bit of Chem 1A stuff first. What are the ways to make violet? Well, one way is, we absorb all colors except for violet. Red, orange, yellow, green, blue, indigo, violet. And so if CV, absorbed all these colors, and the only color it didn't absorb was violet, then the sample would appear violet in color, because all the other colors are essentially filtered out by being absorbed by the crystal violet. What would the absorption spectrum for this look like? The absorption spectrum for this would look like basically all colors would be absorbed here except for violet. Now violet occurs over a range. It's not just at 390. It's between 390 where it blends into indigo, 400 and something. And so here, these are absorbed. And so we see, and this is called an absorption, what? This is called an absorption band versus an absorption line. Do you guys remember line spectra? Line spectra is typically what you see for atomic spectra, single atoms. But bands is what we usually see for molecules and more complicated species. And so we'll see absorption bands and peaks versus absorption lines. Well, is that the only way we can make violet color? No. What's another way we can make violet color? Did you guys do the red food color lab? No? What lab did you do with absorption spectroscopy in Chem 1A? Did you do Beer's law in Chem 1A?
I only remember doing the spectrum and actually seeing the photons light. That's about it.
You just did the atomic spectra where you see the lines? Did you do a spectroscopy experiment where you plotted out Beer's law and determined an unknown concentration? You didn't do that? Oh. That's a required experiment in Chem 1A for El Camino, that is. Okay. Then let me see what I'm going to do. Have you heard of Beer's law? You haven't? Maybe a little bit? Okay. How about the color wheel? Have you done the color wheel? Have you done some? How many of you have not done the color wheel? All right, we'll talk about that. All right, this is one way we can make violet. Another way we can make violet, and there are multiple ways, is by taking a look at the color wheel. Red, orange, yellow, green, blue, and then indigo violet, the range, we'll just group those together. Some people call this purple here. So red, orange, yellow, green, blue, purple, something like that, or violet. When we have this kind of the artist color wheel, what we can do is we can see, you know, if something appears violet in color, then what's one way to get violet? One way to get violet is to, directly across from violet is yellow, green, right here. And so if we take out yellow, green, absorb that, then the remaining colors will add up to violet, blend to violet. And so if we absorb yellow, then we can get that violet color. The absorption spectrum would look quite a bit different in this case. The absorption spectrum would look like this. Okay, so let's figure out where, you know, yellow around here. You know, it's just roughly around here. What we should see is we should see an absorption peak or an absorption band around yellow, like that. And so if we knock out this yellow, then the remaining color should give us violet. And so this would be the like complementary color. Violet. There are other ways we could do it. We can knock out multiple colors. You know, if we knock out multiple colors such that the remaining colors add up to violet, that works too. And if we knock out multiple colors and the remaining colors add up to violet, then we're going to see multiple absorption bands or peaks in the spectrum. But these are two simple ways. We could just say etc. over here. And then you saw, you know, how multiple colors add up to one visible color, and that is when you use the lamps. You guys use the lamps? The hydrogen lamp. You know, hydrogen lamp looks purple. Why does it looks purple? But when you look at the colors, it's actually a mix of red, green, blue, and violet. You know, and those added up to purple. The mercury lamp, etc. Some lamps just emit, those are emission spectra. Those are different than absorption spectra. Emission spectra, they're emitting the photons. Absorption, we're absorbing this and then seeing what the net result is. All right, so the first part of the experiment is we're going to measure the visible spectrum of crystal violet to get an idea of what's causing it, the color. And so we're going to break up the lab into parts. And so the first thing we're going to do is we got to check out a spectrometer and the equipment out of the stockroom. And so we're going to use the LabQuest system to acquire the spectrum. Okay, so go ahead and check out the equipment. We'll get the spectrum, and then let's take a look at the spectrum and see what we got.